Here's another example of a parabola. It's going to end up being a sideways parabola. And when the vertex is at the origin, we'll move it around later, but when the vertex is at the origin, the equation is always going to be y squared equals 4px. So one example would be they give you the geometric information. The focus is at 2, 0. That's the information. And the directrix is the line x equals minus 2. These two have to be equal and opposite for the vertex to end up at the origin, although we're going to shift that later. So that would be one way of having the data presented. That's sort of geometrically. Okay. And I'll talk in a minute about how it might come algebraically. Well, if it's given geometrically, we can start sketching without even getting the equation x squared, y squared equals 4px. But we should figure out p at any rate. So p, remember, I just want to enter. P is just the distance between the focus and the vertex, or the directrix and the vertex, or it's half the distance between the focus and the directrix. It's just going to be 2 here. Okay. And the vertex, might as well say that. That's 0, 0, because it's one of our standard easy examples. Okay. So let's see what we can do with that. So here I've got some axes set up, and the first thing is plot the focus. That's that little X there. Hopefully you can see it on the video. And that's at 2, 0. And then the directrix, that's at the line x equals minus 2. And because these are sideways from each other, that's what's going to make it a sideways parabola. It's going to open, it always opens away from the directrix towards the focus. It kind of curves around the focus. Okay, a little bit like the center of a circle. Certainly, well, somewhat like the center of a circle. Okay, so here's the vertex halfway in between. Don't need any equations for that yet. And then remember, we can also get the endpoints of the lattice rectum that gives us the focal diameter. We're going to have 2 more points, and this is what I had up here. You go 2p on either side of the focus, go parallel to the directrix. So we're going to go up and down here, and so they're both going to have coordinate 2 something. Okay, and you just go up and down from the x-axis. You go up and down by 2p, so that's going to be 2, 4 and 2, minus 4. Okay, so again, without even getting an equation, we've got now 3 points. So there's those points. They're just on the edge. You can hardly see them, but they're at the top and bottom there. Okay, and now I'll just draw with a dotted line the lattice rectum in between them. Okay, and now we do need some more points. We could kind of freehand it here, but it would be nice to have some more points. Now here, now it's time to get the equation. Okay, but we can write it down. All we need to know is p, and we already figured out p. So it's just y squared equals 4px. Oops, too far. Okay, so the equation is just y squared equals 4 times 2 times x, which is 8x. Okay, so do we put in x's or y's? Well, this is a sideways thing, so it's not like for every x there's one y. In fact, there's going to be, for here, like this x had 2 y's. Instead, for every y, there's going to be one x. So you actually should plug in, let's say, 2 simple y values. And let's say, looks to me like y equals plus or minus 2 is pretty good. Y equals 2 is going to give you x equals, so that's going to be 4 over 8. Let's just go ahead and solve this for x. X equals y squared over 8. And so that's going to be x equals 1/2. That's a nice 2, 1, or 1/2, 2. We can plot that. And y equals minus 2 gives us the same value for x. That's the symmetry of the whole thing. X equals 1/2. Okay, and so I just have those ready to plot. Oh yeah, here's the equation, y squared equals 8x. Put a title on it. Okay, and there's plus or minus, or 1/2, plus or minus 2. And now you can just sketch a parabola in between. Might be good to go a little bit beyond the lattice rectum, but you know, that's not such a bad graph. And that's a good place to stop. So let me just say, the information flow could have been very different. We could have been presented with y squared equals 8x, or x equals y squared over 8, or even like 8x minus y squared equals 0. So there, the information flow would be different. The key is always p, and there it's just pattern matching. You need to get it into our standard form, y squared equals blah times x, and then just recognize, okay, if that's 8, that's 4 times 2. So here we went from the 4 times 2 and collected it as an 8. If they tell you y squared equals 8x, you just factor a 4 out. It's going to be 4 times what mystery number times x? Oh yeah, it's going to be a 2. That tells us p equals 2. That allows us to say, okay, there's no weirdness. The vertex is at the origin. We'll shift that later. So we can walk 2 units, p units, in the positive x direction to get the focus. Walk the other way to get the directrix. Got the vertex as 0, and then it just proceeds as before. So different problems have different strategy. I showed you from geometric to algebraic a little bit more, but if you're given the algebra, then you can still figure out the key quantity p, and then just remember that p is how far you walk from the vertex, which for us right now is just 0, 0, how far you walk and in what direction to get to the focus. Let me just write that down. Okay. So remember, once you have p, p tells how far and in what direction, positive or negative, to get from the vertex to the focus. Because p was equal to positive 2 here, and the vertex was the origin, that means you go 2 in the positive direction, and that's the focus. Then you just go the opposite direction to get the directrix, and then it's not too bad. And the reason it's sideways, you know that it's an x equals y squared type. That's going to be sideways. So remember also, if it's x equals y squared type, that's going to be sideways. If it's y equals x squared type, which is much more familiar, that's going to be up or down. Okay, I think that's probably good.